Hello guys, welcome back to a new video. So let me change the view. Yeah, so today we are going to solve this valid Sudoku problem. I've already opened it. Let's just read the question first, then we will solve it. So determine if a 9 cross 9 Sudoku board is valid. Only the field cell need to be validated according to the following rules. These are the rules. Each row must contain 1 to 9 digits without repetition. Each column must contain the same without repetition, and each 3 by 3 9 cross 3 cross 3 sub boxes of grid must contain 1 to 9 digits. Okay, and a Sudoku board partially filled could be valid if not necessarily solvable. Only field cell need to be considered. Okay. Yeah. So this is the input for field cell. We have the this value. It will be in a char, and for this empty, it will be a dot. Okay. Yeah, we have to just return true and false if it is valid according to the rules or not. Yeah, these are the constraints, and yeah. So first of all, I would like to tell you that this is not a Sudoku problem. The name of this problem is valid Sudoku, but this is not a Sudoku problem. There are some rules here which are not exactly same of Sudoku, because here each row must contain 1 to 9 uh, only without repetition, only 1 to 9 these integers, and each column should contain. So empty is also valid, and also like at the same time they have present both. Like for example, this 5 is present for this, and this can be considered for both rows and columns. So yeah, that is different from Sudoku. And also the third condition, this is the 3 cross 3 in this 9 cross 9. So this also should contain 1 to 9 only, and empty is also valid. So we have to check for all these small boxes, 3 cross 3 boxes, all rows and columns. So yeah, this is the problem. Now let's just remove this third rule and just simplify this problem. We have to just check all these only these rows and columns. So this is pretty simple. What we can do is we can just go to each cell, and we will maintain a set for each row. This is 0th row, this is first row, this is second, third, and so forth. So 0 to 8. So we will have a set for each row, and we will just put we will just check the number. If it is already there, then we will if we found a duplicate, we will return false from there only. Similarly, we will do for this column. So let me just quickly write the solution for this. We will come to this 3 cross 3 rule later, so it will be easy for you to understand. So this is pretty much easy. So let's create unordered first. Unordered, if I can write, yes, unordered map of int, that will be the row number, and then we will for against this there will be a unordered set which will have let's say char or integers. Okay, so we will put those chars or integers inside this. We can write char as well or int as well, whatever. So let's just write int. We will see if it works, otherwise we will change it. Yeah, so this is for row. Similarly, what we will gonna do, we are going to write unordered map. Similarly for that, unordered, let me check if we are sharing or not. Yes, it's working. Set of call. So these are the basically two maps which will have this value as the unordered set that will store all the unique values against a row, and this is will be a call whatever ID or index. Yeah, so let me just calculate the number of rows here. That will be the size of the board. just simply this, and this is will be the size of this is how we calculate the size of call. So that this will be the size of here it will be like here whatever the input size will be, so it will get set to this. And then what we have to do is we simply have to just run two for loops, and r equals to 0, r is smaller than rows, and r plus plus. For int c equals to 0, c is smaller than calls, c plus plus. And then we have to get the current value like this. This is char or int, whatever. Let me just write char so that there will be no confusion, and we will change it if it now works. Okay, yeah, so this is char, and then what we have to do is yes, board, board, row and call. So yeah, this will get the current value at rth and cth row and column. And then we have to simply check if our rth row contains this val. If it is not going to be the end, or that is it contains the value, like we have to check like this. Or if it is if the calls contains this should be c dot find val not equals to call of c dot end. I have written here as it should be this. Yeah, so it will check if it present in row, either row or call. If it is present, we will simply return false, that we get a duplicate value. So it cannot be a valid Sudoku according to these rules. So without repetition was the main here. Now this let me just write also, if everything goes well, we will return true, that is it's a valid. Now there is one thing here, we have to only check for filled cells, so we have to skip those other cells. So that will be, so val equals to that dot. We will continue. Yeah, so this will work for these two rules. And now for this, let us understand what is this, how we are going to check. So here for rows and column, we are specifying with the row and column. Now we have to specify this 3 cross 3 this cell, yeah, or we can say this sub matrix of 3 cross 3. We have to somehow like why it's not working. Okay, so we have to check if this contains all 1 to 9 or doesn't contain duplicates. Similarly for this cell, for this, and in this way all these sub matrix of 3 cross 3. Now here we can specify in our code, we can specify a row with this key, row index key. But how we are going to specify a single this 3 cross 3? Can we specify this with an index or a key? Yes. So what we can do is we can divide this row and column by 3. That will give us a unique value for this. For example, we have to specify this, so this will be like for this, it will be like, let me divide 0 by 3, and let's suppose here let's for now suppose 0 by 3. So it will give us 0. So this is so they both give us 0. So this is the first that will represent this first. Similarly, we can do this for 3 by 3. It will give us 1. And for here row also, sorry, call also 3 by 3. So it will be 1. So this 1 and 1 combination, or this 0 and 0 combination, will give us the number of this, like this is the first or the zeroth 3 cross 3 matrix. This 1 cross 1 comma 1 will give us this. So similarly, we have some way to point our matrix. So for that we have to do similar thing. We have to maintain unordered map, and this time we will have a key as a string. So that will be the combination of these two, a unique value. Like for this, the unique value will be 0 0. For this, it will be 1 1, 0 and 1. Yeah, it will be like 0 and 1. And for this, it will be 1 and 1. So we just calculated this 3 and 3. So this will be, we calculated for this. So this is 1 comma 1, and this is 0 comma 1. This is the 0 and 1. So that's how we have the unique value. So we will do the same we have done for other. Let me write the code here quickly. Another set of char, so the value will be char only, and let me write the squares as the name of this. So we have to do the same. We have to check here like this, or square. Before that, we have to build our key, so that key can be built like this: string key, and the key will be like this: to string r plus to string c. So that will give us a unique string value key. So what we can check the squares. Squars dot find. So we have to find with that key. If we can check if that value is present or not. If it is present, then we have to return. So same squares key dot and yeah, and if it is not present, we will simply insert it. So that will be for the first time we are seeing a unique value. So that for that we have to just simply row r dot insert well, call r dot insert well squares key dot insert well. So I guess this is the code. Let me first check this if it is correct or not. Yeah, should be well, not whack. Yeah, we are getting this as false. Let me check once from the very beginning. Yeah, so here we are not dividing it by 3, and also here if you can see we are updating it for r. This should be c. So now let's check this. This should work. Yes, let me submit this quickly and check if it works for all. Yes, hopefully it's working. Now the time complexity, as you can see, 2 for loops r cross c. So it will be simply the rows into cost. Number of rows into cost will be the time complexity of this, and space complexity, if we can see, will be the similar. We are so storing this rows and calls and squares, so at max it can going to be of and cross n. Yeah, so that's about this video. If you like the video, you can hit on the like button. Also consider subscribing, and let me just tick it here. And I have created a playlist for all these these questions, and I have solved this much of questions till now. I am going to solve all these questions. And if you haven't subscribed yet, please consider subscribing, and I will see you in the next video.